4. So what I'm going to do in this video is recall some of the things that we've done and then how it relates to this. You'll notice that the screen is a little bit jumbled here, but all have an important purpose. I'm going to try my best to make sure we don't get too jumbled up, but I'm going to do these two problems throughout this page. All right. So let me just take a step back and recall what Unit 6 is all about. 6.1 was us just learning how to use the chart that we had of the normal distribution. Section 6.2 was the application to an individual of the normal distribution. 6.3 was used to discuss the sample, like if we have a sample space, what's the average and how does that compare to the overall population? And finally, we're going to use this normal distribution to approximate the value of a binomial distribution. All right. So if you recall, 5.3 is the last section we did before break here. And if you recall that nice formula here, the probability of x, ncx times p of x times q of n minus x, just so you recall that the p was the probability of the event happening and q was the probability of not happening. Kind of like I chose those words instead of the success and failure for obvious reasons because we had a couple problems that involved that. Also, what we talked about during 5.3 is the mean of a binomial distribution is n times p, and the standard deviation of a binomial distribution is the square root of n times p times q. We're going to be using this stuff right here for this section. All right, I just wanted to bring up 5.3 and why to solve some of these problems, this would probably be a lot more stressful situation. So we're going to use a normal distribution to solve a little bit more difficult problems that this one cannot satisfy. All right, so let me jump right in. I'm going to go through these parts by doing a problem here. And so this is number 4 from your book. So we have the school enrollment of all 3 to 5-year-old children. 56% are enrolled in school. If a sample of 500 such children is randomly selected, find the probability that at least 250 will be enrolled at school. So if you were going to use 5.3 here, you would have to do the probability of 0, 1, 2, 3, 4, 5, 6, 7, 8, add all those up, all the way up to 250. So you can imagine the workload that would take place if we were going to use our formula from here. So with these larger things, we're going to use the approximation to the binomial distribution. We're going to use this normal distribution, okay? Now, these procedure table is out of your book. This is a great table to kind of make sure that, that you take all the necessary steps. And right about here, you should start recognizing some stuff. Find the corresponding z-values, find the solution. So steps 5 and 6 relate directly to what we've already done in the previous sections. You're going to find the z-score. You're going to find the table. Find the value in the table, and if it's greater than, you're going to take 1 minus that, so on and so forth. You guys should be pretty familiar with that. So let's dive in here, and let's just go through a problem. So the first thing it says, step 1, check to see whether the normal approximation can be used. All right, so that's what it's referring to here is step 1 is we want to see if this is a possibility, okay? So we have to say step 1 here, is let's just see if we can use the approximation as a method of solving this problem. So all we have to do is take the number of people. So this is 500, which is the n. We have 500 people. And then times p, which p is 56%. All right, so I'm going to take it times 0.56, and that would equal, let me grab my notes real quick, that would equal 280. All right, and then I'm also going to take 500 times the event not happening, which is 0.44, which would equal 220. And all I'm doing here is just checking to see whether or not this particular method could solve this problem. And in this case, because they're both greater than or equal to 5, which they are definitely better than that, we can check that off as this is a method we can use to solve this problem. All right, so step number 2 is we need to find the mean and the standard deviation of the problem. So we're going to take n times p. Now what you'll notice is I've actually already found this. N times p was what I used to check to see whether I can use this process. So I'll just rewrite that just so you guys can see that. 500 times 0.56 equals 280. So that's going to be my mean. All right. And then I'm going to find the standard deviation by taking the square root of let's see here, 500 times 0.44. Remember, my 4s are looking terrible today. I can't go on with that going on here. Let's see. There we go. 0.44 times 0.56. And all I'm doing is I'm taking n times p times q. You'll notice if I were to take p plus q together, it equal 1. So my standard deviation comes out to be a nice 11.1. Now we would round to the nearest hundredth if possible, but you'll notice if you type that in your calculator, it comes out as 11.10 if you wanted to put that there. We don't need the 0 though. All right, so I got my 2. I got the, let me put a circle around those. I've got my mean, and I've got my standard deviation. Hopefully maybe you're seeing the writing on the wall here on what my steps will continue being like. Okay, so step number 3 and 4 is what really is new to this section. We've found the mean of standard deviation of binomial distributions, but step 3 and 4 here are where we're going to be using this chart right here. So I want to make sure that I mark this here. So step 3 and 4 are where this chart comes into play, okay? All right, so watch me walk through this. This is really kind of the new stuff we're learning here. So step 3 is simply just to put the problem in context. Find the probability that at least 250 will be enrolled in school. So that means that the probability that x will be greater than or equal to 250. As you recall, at least means greater than or equal to. All right, so I'm going to write the problem in probability notation using x. All right, so probability is greater than or equal to 250. So step 4 is where this chart is going to come into play. So I'm going to look at this chart and determine which one of these I'm going to use. So you'll notice it's greater than or equal to. So I'm going to use this one right here, okay? So I'm going to make an adjustment. So the reason why we have to make this adjustment, if you look at the title of this section, which is the approximation, is that I got to account going back all the way to 2.1 or 2.3 where we had to find the class boundaries, is we want to include. So it was going to change to probability x is greater than 249.5, okay? So again, what I look is I wrote the problem in the context of what it's asking for. Find the probability that at least 250 will be enrolled in school. So probability of at least 250 will be in school. I then took this and looked it up in this category. I found that it's greater than or equal to A, and then I subtracted 0.5 from that value. So it's now 249.5. This part right here, I can't reiterate this enough, is really the new stuff we're learning. It's just a slight adjustment. Because now what you'll notice on part 5 is just, hey, I'm going to find the z value. All right, so I'm going to take this part right here, so x is greater than 249.5, and I'm going to just do what I've been doing this whole unit, which I'm going to take the z-score equals 249.5 minus the mean, which again we found earlier, 280, divided by 11.1. And so I find the z-score equals negative 2.75. All right. That's what I found as a z-score. I'm going to go to my good old chart here. Let's see. Negative 2.75 is right here. All right, so negative 2.75 is 0.003. So probability is, I'll just say equals, so if we transfer this down, it equals 0.003. All right, and we got that from the chart. And then, so just recall, I made this mistake when I was doing this problem earlier, is you'll notice that the greater than, so remember you got to take 1 minus 0.003, because if it's saying greater than, we have to take the minus that, so it would equal 0.0997, which would be our answer. Okay, so again, I want to stress that 5 and 6 are just stuff we've done in the past. It's just this process 3 and 4 of finding the value that we're going to put in our z-score for x. All right, so okay, so I'm going to do problem number 8. See if you can try this on your own. I chose number 8 for a reason, and that is because it requires me to do 2 problems, one less than, one greater than, and so that's why I chose this one. Please pause, try to do it yourself. You can fast forward. You can tell that these steps get a little bit long-winded and a little bit cumbersome a little bit. So let's see here. So I'm going to start out. Let's just see if I can use this particular method. So let me put it in different, let's put it in blue again. So the first step I need to do here, check to see whether the normal approximation can be used. So I'm going to take 180, 180 times 0.6, and we get 108. And then we get 180 times 0.4, and it equals 72. So I can check that off as yes, they are all greater than 5 in both cases. So I can use this method. Problem number 2, part 2, is find the mean. All right, as we talked about, the mean is just taking the n times the p, which I've already found that, which is 108. And then the standard deviation would be the square root of 180 times 0.6 times 0.4, which I come out to be, the standard deviation is 6.57. I'm going to round to the nearest hundredth in this case when I'm using the standard deviation here. All right, so 6.57, so I found both of those. I'm going to put those in red because I'm going to need to find those later, just so I can easily find those in my work. All right, and now comes the part where we're going to have kind of two separate problems here, because if you read it, it's more than 60, but fewer than 100. So I have two parts here. Then I'm going to have to do steps 3 and 4. And this is, again, why I chose this problem, because it allows me to do two problems in one. All right, so I have P. So again, I'm going to put step 3 here. P, x is greater than 60 or more than 60, and P is fewer than 100, so x is less than 100. All right, this is step number 3, very, very important. Step number 3, put that red dot there. Yes, step 3, I have two separate problems because I'm dealing with the between kind of thing. All right, so I'm going to rewrite these. Again, looking at the chart, P is greater than 60. I'm going to look in this chart for P is greater than 60. So the greater than 1 is right here. And so I'm going to look across here and I see that, well, I have to add 0.5 to the value. So instead of being greater than 60, P, x is greater than 60.5. And the reason for that is I don't want to include 60 in my chart. I want all values above 60.5. All right? And in this case, we look at less than 100. You'll notice this one applies to less than 100. And so what we're going to do is subtract 0.5 from that. So really what we're going to be looking for is P is less than 99.5. All right, so let's dive in here. We're going to do the exact same thing we've been doing this whole section. I'm going to find the z-score for this. So I have the z-score is 60.5 minus 108. And that would be, let's see, over 6.57. And this is going to probably bring some alarms to you here, is the z-score for this would be negative 7.23. All right, we'll talk about that here in just a moment. Let's talk about this one, 99.5 minus 108 divided by 6.57. And so we get a z-score of negative 1.29. Now, we're dealing with the between thing here, right? So we're going to find the probability of this happening. Now you'll notice that on our normal distribution, nowhere on our normal distribution do we go to negative 7.23. You'll notice I cap out at negative 3.49. So in this particular case, like we've done in the past, it's kind of beyond our chart. So we just say 0.001 chance of happening. All right, and then on this one, we have negative 1.29. We can definitely find that one on there. Let me bring that up. If I brought my chart, negative 1.29 would be right here. So that's 0.0985, 0.0985. I got a bird who just wanted to come in, learn some math. And then finally, because it's between, we are going to subtract these two probabilities like we've done in the past. So I'm going to take 0.0985 minus 0.0001. So my probability is 0.0984. All right. So, whew, that's a lot of work to that problem. Using the charts is very handy. This is also stuff you can find in your book on those pages there for these charts to reference. Okay. Thank you for your attention. I know it's a long video and I appreciate it. Hope you have a good week. Please know I'll be available during those office hours too.